All right, here is the second example. It's about variation of parameters, the second method. We are going to solve this differential equation. Okay, this is also linear second order differential equation with constant coefficients, but on the right hand side, our function is a bit different. It's not a polynomial function, it's not a linear combination of cosine and sine, or it's not an exponential function, or it's not the product of these three functions, all right? So that's why we're going to use a variation of parameters, which is the more general method. So to solve this one, first we need to start with solving the associated homogeneous equation, right? That is, okay. So that is, here we have 4y double prime plus 36y is equal to 0. So the auxiliary equation would be 4m squared plus 36 is equal to 0. Now from here, what is m? It is negative 36. Negative 36 is divided by 4. It is negative 9. And take square root of both sides. Now we will have plus minus 3i. Right? So now we can write here the first fundamental solution of this one would be, what is it? Cosine of 3x. The second one, y sub 2, would be sine of 3x. Then now we can write the complementary solution of the differential equation, that is c sub 1 times y sub 1 plus c sub 2 times y sub 2. And where y sub 1 equals this and y sub 2 equals this, right? Now in the second step, we need to find the particular solution of this differential equation. So to do this one, we are going to use this variation of parameters, that methods. First, see here, the coefficient of y double prime is not 4. So it is not in standard form. First, we need to bring this into standard form, right? If you just divide both sides by 4, then we would get y double prime plus 9y is equal to 1 over 4 times cosecant of 3x. So this is our f of x, right? So now first we need to find our Wronskian determinants. Capital W is equal to, here we have y sub 1, y sub 2, y sub 1 prime, y sub 2 prime, which is equal to, y sub 1 is cosine of 3x, y sub 2 is sine of 3x. Let me draw a line, vertical line here. And the derivative of this function is minus 3 sine of 3x. The derivative of this function is 3 times cosine of 3x. Okay? All right. So which is equal to, and just cross multiply cosine of 3x times 3 times cosine of 3x. That's equal to 3 times cosine squared of 3x. And because of this minus, here we have plus 3 times sine of 3x times sine of 3x, which is equal to 3 sine squared of 3x. And this 3 is a common factor, and cosine squared of alpha plus sine squared of alpha is equal to 1. That's the first very important trigonometric identity. So this determinant is equal to 3, right? And in the second step, in the next step actually, we need to find capital W sub 1. Sorry, actually first we need to find sub 1, right? So that is the same determinant, only the first column is replaced with 0 and f. So here we have 0, and here we have f, here we have y sub 2 and y sub 2 prime. And which is equal to 0 times y sub 2 prime is equal to 0. So here we have minus y sub 2. Y sub 2 is sine 3x times, what is f? F equals this. So that is equal to 1 over 4 cosecant of 3x, right? And we know that cosecant is 1 over sine, right? So the sine of 3x times cosecant of 3x, that's equal to 1. So this determinant is equal to negative 1 over 4. Okay, and we need to find w sub 2, which is, here we have y sub 1, y sub 1 prime, and here we have 0 and f, the second column, right? This subnotation actually specifies which column is replaced by 0 and f. So that is equal to 0 times y1 sub prime is equal to 0. So that's equal to f times y sub 1. What is y sub 1 is equal to cosine 3x, and f is equal to this. So here we have 1 over 4 times cosecant of 3x times y sub 1. Y sub 1 is cosine of 3x, right? Or if you just simplify this, 1 over 4 cosecant of 3x is 1 over sine, and cosine over sine, that is cotangent of 3x. That is W2, our second determinant, right? So now we can evaluate the value of y sub 1 prime, which is equal to capital W sub 1 over capital W, that is Wronskian determinant, and this W sub 1 is equal to negative 1 over 4 over this capital W is equal to 3, so that's equal to negative 1 over 12. And here u sub 2 prime is equal to w sub 2 over w is equal to w sub 2 is this 1 over 4 cotangent of 3x over, and this w is 3, which is equal to 1 over 12 times cotangent of 3x. Right. Okay, so actually we have found this y1 sub prime, y2 sub, what is it? Y2 prime, right? U sub 1 prime, which is equal to minus 1 over 12, and u sub 2 prime, which is equal to 1 over 12 cotangent of 3x. Okay, so now from here we need to find u1 and u2. So then here we have u1 would be the integral, right? Here we have minus 1 over 12 dx. Because on the right hand side, u1 prime equals minus 1 over 12x, right? If you just integrate both sides, and here on the left hand side we have u sub 1. If you integrate this, and minus 1 over 12x. And once again, you're just ignoring the constant, okay? Because we don't have to write this. All right, and how about u sub 2, that is integral, and here we have 1 over 12 cosecant, cotangent of 3x dx. Now if you evaluate this thing is equal to, what is it, 1, okay, that is equal to 1 over 36 times natural logarithm of sine 3x, right? Because this cotangent is cosine over sine, and we can bring this cosine into this differential, right? At that time, we will have here, what is it? D sine, actually we have cosine over sine, right? Sine of 3x. This thing is equal to 3 times cosine of 3x dx, right? And here we have 36, 3 over 36 equals 1 over 12. So here we have cosine over sine, here we have cosine of 3x, we already have sine of x. So here we have integral du over u, which is equal to natural logarithm of u. So our u is here sine of 3x, okay? Then the general solution of the equation would be, what is it? Here y, general solution of the given differential equation would be the sum of the complementary solution and the particular solution. And we know what is this complementary solution, that is c sub 1 times cosine of 3x plus particular solution is, second part is c sub 2, it is sine of 3x plus, now let's write this particular solution. Particular solution is u sub 1 times y sub 1, and u sub 1 equals this, that is negative 1 over 12x times, here we have y sub 1, that is cosine of 3x, plus here we have u sub 2, that's equal to this, so that is 1 over 36 times natural logarithm of sine of 3x times, now here we have, what is it, y sub 2, and y sub 2 is sine of 3x. Okay, and if you just write this without, how is it, can we simplify further? No. So actually that is the general solution of the given differential equation. Okay, so maybe I can just remove this bracket. So dot, 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 let me change the pencil color. So that would be the general solution of the given differential equation is c sub 1 times cosine of 3x plus c sub 2 times sine of 3x minus, this one is x over 12 times cosine of 3x, and this one is plus 1 over 36 times sine of 3x, I think a complex like this, and natural logarithm of sine of 3x. Okay, so unfortunately it doesn't fit here. Let me just write it a bit in a more compact form. So here plus, and here we have sine of 3x over 36 times natural logarithm of sine of 3x. Okay, so this is the general solution of the given differential equation. That is the solution of this differential equation. Okay,